A lot of electronics programs don't fail in the lab. They fail at scale when materials that once behaved perfectly start affecting yields, throughput, or qualification timelines. A polyacrylic acid that performs exactly as expected during evaluation can perform differently once production volumes increase. Timelines slip, materials need to be requalified, and manufacturing slows, not necessarily because demand changed, but because the material did. This is where scale changes the equation. At scale, three things start to drift: molecular control, impurity profiles, and process consistency. These shifts rarely show up during initial qualification. They appear later, during long production runs, site-to-site transfers, or when higher throughput pushes the process window. That's why electronics-grade polyacrylic acid isn't defined by lab-scale performance. It's defined by whether purity, molecular weight, and batch-to-batch behavior remain stable as volumes increase. At Polysciences, we work with electronics teams to assess whether a polyacrylic acid can scale without performance drift. We help identify scale-related risks before they impact production timelines. If you're moving from evaluation into full-scale manufacturing, our technical team is ready to help. Visit polysciences.com to contact our team.